the plan for this talk is I want to tell a very short story. I was originally planning on doing the whole what is new in Elixir 1.5, but you can go and read the changelog and everything's there. So I had a change of plans, and I want to tell a short story about something new that we discovered with Elixir 1.5, and it has a lot of potential. So we're really excited about it. So it's the feature that no one knew, okay? So the end result of this feature, we can actually see today. So if you get Elixir 1.5 in your machines and you're running Erlang 20, if you have something, for example, like access fetch, if you call a function like access fetch passing full bar, and you pass it invalid arguments, you get, let me reduce this, you get this very beautiful and long error message now. So in previous Elixir version, so what is happening here? We are calling a function and we are passing arguments that do not match any of the clauses of that function. Basically that function is saying, look, I don't accept those arguments. And before Elixir 1.5, everything that I highlighted here would not show, right? Everything it would say would be at the top. It would say no function clause matching in access fetch. And then it would have the stack trace. And if you kind of wanted to find out why that did not work, you had to pick the arguments out of the stack trace in the last line, and that was a little bit awkward. So now we can see that we get all this great amount of information. We say exactly, which arguments are actually trying to pass to that function. And if you are on IX, we show that with syntax highlighting. And then we also show what are the clauses, what is the actual implementation of that function. And we say exactly why that particular clause did not match. So for example, the first argument is the atom foo, but the first clause is expecting a struct that's not going to match. So we show here in red, okay? It's exactly here what went wrong. And then we say, in the next clause, we are expecting the first argument to be a map, but we are passing an atom. That's not going to work. So we show really detailed information about what went wrong and why none of those clauses match and how you can move forward from there. So this is much better. And what is really interesting about this is that if you had, so Elixir 1.5 was released like this month, like a couple weeks ago, right? So if you asked us at the beginning of the year when we started preparing the work for Elixir 1.5, like, hey, can we have this feature? We would have said no, right? We're like, well, we are not quite sure how to implement it. It may require changes to Erlang itself, or it may require a lot of code. This is actually quite complex to do it. But at some point, we implemented this in one day. At some point, it became obvious how to implement this feature. And that's because of the feature that no one knew, all right? So what is this feature, okay? So in order to understand how this works, we need to talk a little bit about the Elixir compiler, how Elixir actually works internally, okay? So one of the first things that Elixir does, so you have your mix project, you have your Elixir project, and then every time you call something like mix compile to compile your code, one of the things that it does is that it's going to get the source files in your project and is going to convert that to Elixir AST. And that's a process that we can even do in the shell, right? So we can say something like quote do, and we pass 1 plus 2. And that result that we got returned there, that's the Elixir AST, that's the code represented in Elixir data structures, okay? So it's the Elixir abstract syntax tree, the AST. So code represented as data structure. So that's the first process that we do when we are compiling code. So you can think that the Elixir compiler goes kind of like this. I'm going to write some pseudocode here. So first we have the file, right? And then we want to read the file. And after we read the file, we get a string, right? With the contents of the file, the contents of your Elixir source code. Then the next thing we do is that we actually convert this string, this text we got from the file, we convert it to Elixir AST, which is this process we kind of just saw right now. And then what we do is that we expand all of the macros in the Elixir AST. So we go through the AST and we kind of go expanding all the macros, everything we can expand. And then that returns still Elixir AST, but without macros, with all code expansion that we could possibly do already done. And then we get this AST, so we get this final Elixir AST, and we convert that to Erlang AST, okay? And then after we convert that to the Erlang AST, we feed this information to the Erlang compiler. So we are leveraging the whole infrastructure that comes with Erlang for compiling stuff. We just say, hey, now compile everything. And what is the end result of this process, right? The end result of this process are bin files. Okay, so this is obviously pseudocode. If I try to execute it, it's going to say there is no such function. But that's kind of the process. And at the end of the process, the output, it's a bin file that we write to disk. It's a bin file containing all the information that the virtual machine needs to run that code. So every time we call a function, okay, in our application, so for example, string, so every time we call something like string down case foo, in order for this code to execute, we need to have the bin file, the bytecode for the string module somewhere. And there is actually a module in Erlang that tells this for us. There's a module called code, and we can say code which, and pass the string module. And this is going to return the location of the bin file, the file with everything that we need about the string module, where it is in the file system, in this case, where it is on my machine, okay? So this is neat. So we can access the bin file. And okay, so now we know that there's this bin file and it exists. And what is a bin file? What is actually inside of it? How does it work? Okay, a bin file, it's made of a bunch of chunks. It's kind of like a key value thing where you have a key and a value. It's a bunch of binary. Let's dig a little bit deeper, right? So we have this. What I'm going to do, and this works for every module, right? So for example, we have a tuple module, which is a smaller module than the string one. And we can find the location for the tuple bin file. I want to store that somewhere because we're going to need it a couple times, right? So now I have this tuple path variable that has the location of the tuple bin file. And now I want to see what is actually in this bin file. So Erlang also ships with a module called binlib, which is a bunch of functions to work with bin files. And they have this function called allChunks that expects the path to a bin file. And it's going to return all of the chunks. So a bin file is made of chunks. And those chunks are like key values, right? So let's invoke that. And this is what we get, right? So when we get all of the chunks of a bin file, we see that it returns a tuple saying, okay, the name of the module that is actually there. And it returns a list of tuples, where the first element here is always something with 4 characters. This is the key. Each chunk is identified with 4 characters, okay? And it has a blob of binary, which is whatever you want it to be. A lot of these things, they are internal. You should not, those are things that the virtual machine needs to load code and make everything work. We should not expect it to be a certain format. You should not rely on it in any way. A lot of those, so they are completely internal. Some, they are actually exposed to developers. And you can actually add whatever chunk you want to this, right? You're free to add your own chunks. It's like a key value store. You can add whatever you want as long as you don't override something that it's already there. So for example, Elixir uses it to store documentation. Can you see this chunk here, exdc? So this is where Elixir stores documentation when we compile your files. So every time you say something like htuple to access the documentation of a module, what we actually do is that we find the bin file, we get that documentation chunk out of there, and then we find the documentation for the module or for a given function in that module that accesses documentation for, right? So there is a lot of potential in those bin files, right? And something else that we also have in the bin file is that in the bin file, we also store the Erlang AST. Remember when I was talking about the compilation process, right? And then I said, well, we have the file, and then we got the Elixir AST, and at some point we get the Erlang AST, and we compile. This Erlang AST, it's actually stored in the bin file as well. We can actually fetch it. So instead of getting all chunks, let's say I want to get the abstract code chunk. And what we see here, okay, all this big data structure that we got here is our code represented in the Erlang AST, in the Erlang abstract format. Okay, so for example, we can see that the tuple module here, it has a function named toList that expects one argument, okay, and this function has one clause that expects a variable, and this function is on line 147. One of the features that actually came with Elixir 1.5 is that we can actually do this. We can say, I want to open the the toList function in the tuple module. And then if you run this from IX, it actually opens exactly there for you. So we can see here, so we can see the implementation of that function, right? It's a function called toList. It indeed expects one argument, right? And all it does is to delegate to the underlying Erlang tuple toList function, right? So all that is what we saw here when we saw this represented in Erlang code, okay? So at this point, you may be wondering, right? So cool that we have the Erlang AST, but why are we storing the Erlang AST there, right? And that's because this was a explicit design decision. We chose from the beginning to use the Erlang compiler so we can leverage everything that Erlang has already built in terms of compiler optimizations and all this kind of stuff. It was a design decision. It was a explicit choice, right? We wanted to be as semantically close as possible to Erlang. And the other reason we did that is that a bunch of tools that we use every day, they actually require this Erlang chunk, the Erlang abstract syntax to be available. So for example, Dialyzer, it requires the Erlang abstract format to be available. So if you ever use Dialyzer in your project, it's actually doing this kind of process that I just said about, where you need to find the bin file, and then you open up the bin file, you get some particular chunk, and you get the Erlang AST out of that chunk. Cover, if you get test coverage in your project, is doing a similar process. It gets the original source code, and then it modifies it somehow and compiles it again. So this is interesting, but this also implies that we lose information. So I was talking about cover. If you run coverages in your projects, you know that sometimes the coverage is off, right? And that's because every time we translate from Elixir to Erlang, there is some loss of information in that process. We can even see it here, right? You can see that the variable here, it's not called tuple. In our source code, it's called tuple. But here, it is a version variable. It's called tuple at 1. Because if we rebind, we need to version the variables. So there's always some loss of information. And that makes, so it's good to have the Erlang AST because it means we can use the tools that exist today. But sometimes, those tools, they are not optimal, right? Like cover, it's not, sometimes it's a little bit off. So we start to ask. So we started to think the following, well, it's awesome that we can use everything that Erlang has to offer us. But what if we want to have better coverage tools, right? For those tools to work efficiently, we need to have actually the Elixir AST in there. We want to have the original Elixir code, right? We don't want to have the Erlang code. So we thought, well, what if we just store the Elixir AST? And when we thought about doing that, we were really thinking about the futures. Like, well, maybe in the future, we want to leverage these ideas. So let's get prepared now. So if whenever we want to do it, we'll be ready, right? So it was really thinking about the future. So what if we store the Elixir AST? And then we started to investigate. And then we realized that those AST chunks, the metadata about your code, it's actually 50% of the bin file, right? So if we store the Elixir AST and the Erlang AST, that's going to actually cause a big impact on the size of the bin files. And there are some code that is problematic. For example, I called string down case, right? Every time I call string down case, we have part of the Unicode database embedded in the string module that knows how to, for example, handle my name, right? So, and this is a large, so that bin file can probably get close to 1 megabyte and things like that. And there are places where people are using Elixir, like embedded devices, where actually this kind of space matters, okay? So we said, well, so apparently we cannot just, if we add the Elixir AST and we also keep the Erlang AST, that's going to be an issue, right? Because the bin size is going to grow. And on the other hand, we cannot simply, remove the Erlang AST because a bunch of tools like Dialyzer and Cover, they require this information. That's when we realized that actually there's something wrong about this process, because why are the tools that we use, like I'm saying, the debugger, Cover, Dialyzer, why are those tools actually expecting the Erlang AST to be there? You should not expect the Erlang AST to be there. What it needs to do is like, well, I don't actually care what is in the bin file, but as long as we can spit something out, as long as that bin file can spit the Erlang code for me, I'm fine. I don't need the Erlang code to be there, but I need the bin file to be able to give it to me, right? So we need a new layer of abstraction, right? Like abstractions, they're like Oreos. The more layers you have, the better it gets, right? So what we did is that we actually sent a pull request to the OTP team, and this pull request was accepted. And we can actually now have an idea what this pull request does. So we are now introducing a new chunk. Remember that the bin file, it has a bunch of chunks, okay? We proposed a new chunk. A chunk, remember the chunks are all identified by 4 letters. So this is the DBGI chunk, which implies the Debug Info chunk. And in this chunk, we don't have Elixir AST, we don't have Erlang AST, we have metadata only, right? So this chunk is a bunch of metadata. It should not rely on its contents. But from the metadata, you can ask and say, hey, can you actually give me Erlang code? Can you actually give me Elixir code? And then the metadata may say yes or no to that question. So that's what we did. We sent this pull request, and it was accepted by the OTP team, and it's there in Erlang 20. So now we're starting to put the pieces together, right? Because now, when you're using Elixir 1.5 and Erlang 20, and that's why some of those features that we have in Elixir 1.5, they only work with Erlang 20, is actually because of this. Because now we have the Elixir AST, and when you're running on Erlang 20, we are actually storing the Elixir AST in the bin files. But if we're running Erlang 20, all of the tools that we had before, they still work, right? Cover still works, the dialyzer still works, exactly because Erlang is also asking now, instead of saying, I want to find the Erlang code, it's now asking, hey, can you give me the Erlang code? And we say, yes, of course we can. Here's the Erlang code for you. And then all of those tools, they still work. So that's what we did, right? So this is the feature that no one did. We simply said, okay, let's have this small abstraction where we can say, where the tools now ask, hey, can you actually give me Elixir code? Can you actually give me Erlang code? And that's there. And now we can store the Elixir AST in the bin files, and the Elixir AST is there. So we did this thinking about the future, right? Like, this is going to be great to have in the future, right? I think this was merged at some point, maybe 26 April. So this was merged about 3 months ago, let's say, 3, 4. And it was there. We had this feature. And then sometime later, someone opened this issue, okay? Someone opened this issue where he was saying, how to debug quickly in Phoenix and Elixir. And this is a really well-written issue, okay, where he says, well, I'm learning Elixir in Phoenix, and when something goes wrong, here's what I do. I go, like, imagine that I call a dependency with the wrong argument. I open up the dependency, and then I need to add like some IO inspect calls, and then I need to recompile that dependency, and then I need to check the documentation. And I was reading it. I was like, all right, I do this too, right? And then he was like, and this is horrible. And then I'm like, oh, it's horrible. All right, we need to make it better, right? And then he goes to give great suggestions of how we can improve this process. And we actually adopted all those suggestions by Elixir 1.5. But here, at part of this issue, he has this screenshot, okay? And this is the no function clause matching that I started talking at the beginning of the talk, right? So here's what he got in Phoenix. It says no function clause matching in keyword pop. It doesn't say what is the proper argument it expects. It doesn't say what it actually passed and made it go wrong, right? This is a actually really horrible error message, okay? So I was like, okay, point taken, we need to improve this whole process altogether. Right? And then when we were thinking about how can we prove this thing, the feature that no one knew, that we were not expecting anything from it, came to mind. It's like, wait, we actually have the Elixir AST now, which means that when there's a no function clause matching error, we can actually get the arguments that the user tried to call, we can get the source code, we can try to run each of those arguments against the source code and tell the user exactly what went wrong. We open up this issue to discuss suggestions. And this is the thing that we came for this exactly kind of error. So now, it says no function clause matching access fetch. But as we saw in the terminal, if you come here to the bottom, we say now, well, we're trying to call access fetch. And by the way, here's the documentation in case you want to go and see it. It was called with 2 arguments. You can click and you can see the arguments. And we say exactly what are the clauses available, what we try to call, and what failed and what did not fail. Okay? So if you're running Phoenix in Elixir 1.5 and Erlang 20, you're going to get those reports, right? So these small features started to go to the whole ecosystem, right? And that's exactly how it works. So let's go back to the beginning of the talk, right? Let's tie this up. Okay, so when we do access fetch, foobar, and any other function clause error, right? We are going to say now, we're going to show the arguments explicitly, and we're also going to show the function clauses that we try to call. And every time it fails, right, it gets something in red. It's because we could not match that particular place, okay? And the way it works is that we have a new function in Elixir called exception blame. And what it does is that, so let's open the source. So what this function does is that every time, you're not going to call it directly, the tools like Plug or Phoenix during development, IX, the test framework, they are going to call it for you because it can be expensive, this process. But what we are doing here is that every time there's an exception, if you give it exception blame, blame is going to try to add extra information to it. It's going to tell more, it's going to try to add more things about the exception. And the only exception we handle right now is function clause error. But we can see kind of here what it does is the process that we saw during this talk. So you can see here that the first thing it does is that, so for example, if you have a function clause error in the access module or in the string module or the keyword module, first we try to get the bin file for that module, and then we say, hey, does this module have a debug info chunk, which is the chunk that we added to OTP? If it has a debug info chunk, I actually want the Elixir code from this debug info chunk. And then I get all the definitions, and then we go through the process of checking what went right and what went wrong. And this is just one of the many features that we got from the simple fact that we are storing Elixir AST there. So another feature that we have in Elixir 1.5 is that we have breakpoints in IX. So remember that the bug report said, well, then I need to change the dependency, I need to add IO inspect calls, and then I need to recompile the code. Now I no longer need to do that. So for example, if there's something wrong with the URI, the code query function, I can set a breakpoint directly from IX, right? So now I set the breakpoint, and when I call this code, let's call it. And then I'm going to pass foobar. And then, so I'm going to call this function, passing a string I want to decode and the initial map value. It reaches the breakpoint. It's saying, look, I reached the breakpoint in the URI decode query function, right? And it says, I am exactly on this line right here where we have the query and the map variables. And I can actually go and say, okay, so what are the variables that I have assigned right now? We can access the variables. I have query, I have map, so I can access them. We can actually type, where am I, and get information about the code again. If you want a bigger radius, you call, where am I 10, and it's going to show more information around the code, right? And you can even do things like just type open, and Elixir is going to open up the editor exactly where the breakpoint is right now. So we have all those wonderful facilities to help debugging the code, and all of it works because of that chunk, right? Because now we have the Elixir AST, so now we can do a bunch of crazier things and change how your code was defined. And there is one last thing that happened just this week, 15th, like 2 or 3 days ago, that happened because of this chunk, which is Elixir Script 0.30. It was released a couple days ago. And this release is very different from the previous Elixir Script ones, because now it can compile Elixir code to JavaScript on the fly. So what it happens now is that, imagine that you're typing Elixir code, and then Elixir Script code, and then you call something from the tuple module, something from the string module, whatever, you call some Elixir code. When you do that, the Elixir Script compiler is going to it's going to get the Elixir AST from the bin file and compile that to JavaScript on the fly. So you can call all the Elixir standard library. You can call any of your dependencies, right? And then it's going to find everything that you're calling and compile to JavaScript on the fly, exactly because it can actually get the Elixir AST now and transform that into JavaScript, right? So this feature, it has a lot of potential, because now that we have the Elixir AST, we can stay closer to the code that we actually write, and we can do more relevant information, more relevant debugging, right? So if someone wants to actually have a better coverage tool for Elixir that understands all of Elixir semantics, okay, it's actually possible now. So that's the feature that no one knew. That's what I wanted to share with you. I think it's a very exciting feature that is going to allow a lot of interesting developments with Elixir for the next 2-3 years even long-term developments. And I hope you enjoy it. Thank you.
Thank you, Jose. So we have a good 10 minutes for questions to Jose, like maybe inspired by this, maybe things you want to ask that you never dare to ask him, right? But just like, you know, just bear in mind that it's a public arena. So we're going to just go around with the mic. And if you have anything to ask, just like raise your hand and I'll run to you and you can ask, okay? Although I don't have a mic right now.
I can also repeat the question. No, there is a mic. There is a mic. Where's Mike?
Mike's outside, actually.
Hey.
Hello.
Jose, thanks for the talk. You mentioned during the talk that when you created Elixir, you decided that you would compile to Erlang EST. And other languages that build on the Erlang VM, like I think LFE decided to compile to core instead. So is it a decision that you regretted, or you think that that was a good decision? And what was behind the decision?
Yeah, so it's not a decision I regret. I think that one of the benefits of taking the decision of compiling to Erlang is that it also allows us to be restrained. Because, so for example, if I think back like 5 years when you're designing the language, there are a bunch of design decisions you can take. And the fact that I set up some constraints, like, you know, we need to do that, needs to be expressible with the Erlang AST. It allows us to focus on the important parts of the problem. And there are like a couple times, really, very few times, where I would say, this restriction is annoying. But given the fact that we can leverage all of the Erlang optimizations, given the fact that we can leverage all the tools that come with Erlang, I'm still like 99% happy that we went with this direction. Now we have the choice to change it in the future, but we're not in a hurry. Thank you.
Thank you. Anyone else? Oh, sorry.
Hi, thanks for the talk. What you hinted at, like, you know, you were thinking that this was something in the very, very future that you were doing because of possibly features that you might possibly have in mind, and I was wondering if you could hint at what you thought some of those might be, the reason behind you making this change in the first place. What might be to come that you thought of?
Right. So yeah, that's a very good question. So one of the things was exactly the Elixir Script work. So now, you know, even if you want now to, because compiling to, as I said, compiling to Erlang means like loss of information. Some of the idioms, they would not be carried over. And now those idioms, they can be carried over. So the benefits of Elixir Script is something that we were talking with Brian Joseph for quite some time. And he was working against Elixir Master exactly because of this for a while. But even things like if you want to go a little bit more crazy and say, well, what if we want to have a type system, right? That's something that we can actually do now because, yeah, simply because, you know, we have the ST there, and then we can type the idioms that we are using and not lose the information. So that's this. So one of the issues that happen with Dialyzer, for example, is that when you use protocols in Elixir, basically you throw Dialyzer away. Like it's just when we define a protocol in Elixir for Dialyzer, that protocol can accept anything. And now that we have this information, you may even not want a type system, you may want a dialyzer that is actually aware of Elixir code and can understand protocols better, that will be possible too. So it just generally opens up the possibilities about everything you want to do. Source code reconstruction now, it's easier because before you'd have to get the Erlang code, translate it to Elixir code, and it was kind of messy. That's also easier now, so there's a lot of possibilities really. Yeah. You're welcome.
Thanks. There was another hand. Yeah.
This is the first time I've seen Elixir Script, and I was wondering if this is something that you're using in production or if you know anyone that is.
That's a question that would be better for Brian Joseph. I am not that involved, yeah. But yeah. More questions?
Oh, yeah.
Here. Someone from here should ask next.
I do need to do more exercise, so that's pretty good.
When you showed the example earlier, can you reconstruct pretty much the original Elixir source code? Sorry, can you construct exactly the Elixir source code? And the point of the question is, could you use this to write a nice pretty printer for Elixir code?
So,
You know, if you want something where you can chuck a bunch of, you know,
no and yes. So you can't use that to reconstruct the Elixir code. That's a very good question. So, so remember this process here, where we had all those steps for the compiler? What we are storing there, it's the expanded Elixir EST. All right, so what we are storing there, like the macros, they have already been expanded. So you don't have, so you cannot reconstruct like the fully original Elixir code as the user typed it, because the macros have been expanded, but this is by choice because, for example, things like Elixir Script, it doesn't really care about the macro expansion. It just wants the final result of that. And it actually simplifies the job that things like an Elixir Script or even a potential type system could do. The good news is that and I think Louis is going to talk about it maybe. So the good news is that a pretty printer does not, it works with the original file. It doesn't, so the pretty printer hooks right about here, right about the file and read file. It doesn't need, and things that are done later in the process. So yes, we can have a pretty printer, but we could have had it in the past. It's not related to what I said in this talk. And there is a Google Summer of Code project that is working on that. Louis is working on that as well. So we may see it soon. All right, cool.
Thank you. Any other question? Then I'll ask a question. You just mentioned Google Summer of Code. I was actually curious to know how it went. It's about to wrap up, I guess. So how did it go? How was it?
Yeah, so I think it, so Google Summer of Code, for those who are not familiar with it, it's a project, it's an event kind of thing organized by Google where you have students contributing to open source projects. And we have participated, I think this is our third year participating in some shape. So the first, we've participated throughout the year. So for example, if you use Windows and then we have a Windows installer for Elixir, that was done as part of the Google Summer of Code project. So we got different kinds of feedback throughout the years from Google Summer of Code. The EXPRI functionality that exists for a long time in Elixir, and it was expanded in Elixir 1.5, it actually came from also Google Summer of Code project. And this year we had two projects. So one working on a pretty printer for Elixir code, so no more style guides, no more, how should I indent my code discussions? The pretty printer is supposed to get your code and pretty print it for you and handle it for you. That's one of the projects that we have right now, and it's going well. We already did some improvements to Elixir to make that process easier. Maybe Luis is going to talk about it. I don't know. But and the other project, unfortunately, the student disappeared as soon as the project started. And that other project was supposed to be a language server protocol. So we have a bunch of programming languages and we have a bunch of editors, right? And each of those editors, they integrate with each programming language in a different way, right? So you have like an M per N kind of setup where you need to, all those editors need to know how to talk all those different languages. So Microsoft had the idea of building a language server protocol where you have one format that the language and the editors, they need to follow, and then they can all talk to each other without re-implementing everything over and over again. And the goal was to implement something like this for Elixir, but the student did not show up. But the good news is that there was someone already working on that. He started working as the Google Storm of Code process started, and now he's continuing the work. So we may see it after all. But yeah, so that's kind of the status update. It finishes next week, and we'll see.
Thank you. That's exciting. So you see, there's always an opportunity to contribute, even in the face of I guess like a mystery, like a person disappearing. That's pretty good. Okay, so I guess like we should give just like round of applause for José. Thank you for.
All right, thank you.
Okay.
Thank you.